You switch from home Wi-Fi to mobile data on the train, or you flip on a VPN before a flight, and instead of your chat list Telegram hands you a bare login screen, no chats, no contacts, just a box asking for your phone number again. You didn't log out, you didn't reinstall the app, you didn't touch a single setting, but there you are typing your number back in and waiting on a code like the app forgot you exist. I run managed hosting and proxy infrastructure for Telegram, so tickets like that land on my desk on a loop, usually with the subject line something like Telegram broke or my account got hacked. It almost never has. And once you understand what's actually happening, the pattern is consistent enough that I can usually guess the cause before the client finishes explaining it. Telegram's session system pays very close attention to the network you're connecting from. And when that network changes in the wrong way, it treats the change as a risk signal rather than a normal, boring event. None of this is a bug, and it isn't random either. Here's what's actually happening underneath. Because once you see the mechanics, those login prompts stop feeling like the app turned against you. When you log into Telegram, your app and Telegram servers negotiate something called an auth key as part of the mtproto protocol. That key is what identifies your session, not a password stored on your phone, not a cookie sitting in a browser, not anything your device manages on its own. Every session you have running shows up as its own entry under Settings, Devices, whether that's your phone, a desktop app on a laptop, or a linked device sitting somewhere else entirely, and each one holds its own separate auth key issued at the moment you logged in. Logging out, on Telegram's end, really just means the server made a decision to kill that specific auth key. Your phone didn't choose to log you out on its own. It's simply reflecting a call that already happened somewhere on Telegram's side before your screen even changed. That distinction is worth sitting with because it tells you the trigger is almost always something the server noticed about your connection at the moment you try to use it, not anything that happened locally on the phone itself. Telegram doesn't publish the exact formula it uses to score a session as risky, and I'm not going to pretend I have inside knowledge of their backend because I don't. But the shape of the protocol tells you what data is even available for the server to make that call, and it lines up closely with the patterns I see running hosting and proxy setups for real clients day after day. It isn't guesswork on my end, it's just watching the same failure mode repeat across dozens of unrelated accounts. The server can see the IP address you're connecting from and its ASN, which tells it exactly which network operator or hosting provider owns that address. It can tell whether that IP looks like a home broadband connection, a mobile carrier tower, or a rack in a data center somewhere. It can measure how far the new IP sits from your last known location, and a jump from Singapore to Frankfurt in the space of an hour reads very differently than a jump from your living room to your office 2 streets away. Beyond the network, the server also gets device metadata attached to every single connection, things like device model, system version, and app version, so it can tell if a session suddenly looks like it's coming from a completely different phone. And it tracks frequency, meaning how often that particular auth key has shown up on a brand new network inside a short window. None of that is unusual for a messaging service that has to worry seriously about account takeover. The trade-off is that the exact same signals catching a stolen session also catch a normal person who just changed Wi-Fi networks, switched carriers, or routed traffic through a proxy for the day, a session that's been sitting quietly on the same home IP for weeks, and then suddenly appears on a data center IP in a different country, looks from the server side exactly like what session hijacking looks like. Maybe someone stole the auth key or intercepted it somehow and is now running it from their own machine on the other side of the planet. Telegram genuinely can't tell that scenario apart from you just connecting through a VPN exit node before a flight, so it defaults to the safer assumption every time and forces a fresh login rather than take the risk. This gets worse fast if the new IP carries a bad reputation for Telegram traffic specifically. Data center and hosting ranges get hammered constantly by automation, scraping tools, and account farming operations, so an IP that's already been used by dozens of unrelated Telegram sessions before you ever touched it carries far more suspicion than a plain residential IP that's only ever seen your traffic and nobody else's. Connect through a shared proxy or a VPN provider that recycles the same handful of exit IPSA across thousands of customers, and you're walking straight into the exact pattern that Telegram's risk model was built to catch. Frequency plays into it as well. One network change on its own is a fairly minor signal, the kind of thing that barely registers. Hopping across 5 different EPs in 3 different countries inside a single day, which happens naturally if you're rotating through proxy exit nodes on a schedule, reads completely differently to a risk model than someone who simply moved from their office to a coffee shop down the street. The model isn't judging the proxy itself, it's judging how erratic the pattern looks when it's stacked up against everything else the server already knows about that account. Two-factor authentication changes the calculus quite a bit here. If your account only has SMS-based login and no cloud password set under settings, privacy and security, two-step verification, Telegram genuinely has fewer ways to confirm it's really you when one of these risky signals shows up. The safest move available to the server in that situation is to just kill the session outright and make you prove yourself again from scratch, because it has nothing else to lean on besides that one SMS code. A cloud password doesn't stop network-based logouts from happening entirely. That mechanism is always going to be there, but it does hand the server an extra trust signal it can lean on instead of jumping straight to a full re-login every single time something looks slightly off. Accounts that have two-step verification switched on tend to get noticeably smoother treatment around these session challenges simply because there's a second layer of proof sitting behind the account beyond just whether the device happens to have the SMS code. This is the part I deal with directly every week, running hosting and proxy infrastructure for people who actually depend on Telegram staying logged in. The pattern that causes the most session churn isn't using a proxy at all, it's inconsistency. An account that always connects through the same mtproto proxy or the same SOCKS 5 endpoint from roughly the same geographic location builds up a stable pattern that the server has no real reason to question over time. An account that gets bounced through a different exit node every single session, especially across data center IP ranges with mixed reputations, looks unstable to the server no matter how legitimate the actual use behind it is. The same logic applies just as strongly to a bot or an automated user bot running on a VPS. If that provider's IP range has already carried a lot of unrelated Telegram traffic before you ever set up your instance, you inherit some of that reputation, whether it's fair to you or not, because the server has no way to know your instance is different. Move that VPS to a fresh IP or switch the bot over to a completely new host, and you reset whatever trust the old IP had slowly built up, which usually means a fresh round of login challenges right as you're trying to get the thing running again. There's no setting anywhere that turns network-based session checks off completely. And honestly, you wouldn't actually want one even if it existed, since it's the exact same mechanism that protects you the day somebody else gets hold of a stolen off key belonging to your account. But there are a handful of concrete habits that genuinely cut down how often you run into this in practice. Set a cloud password under two-step verification if you haven't already, and pick something you actually remember, since losing it locks you out in a much worse way than a login prompt ever could. It's the single clearest thing you can do to give Telegram something more to work with than just an IP address when it's deciding whether a session is really you. Keep a consistent exit point if you're routing through a proxy or a VPN at all. Pick one location and one endpoint and stay on it, rather than rotating exit nodes from session to session out of habit or because a tool defaults to it. The server rewards a boring, predictable pattern, and a proxy setup that behaves like a real fixed location will get you far fewer of these forced relogins than one that jumps around. Check settings, devices every so often, maybe once a month if you use Telegram heavily. If you ever spot a session sitting there that you don't recognize, terminate that one specifically right away instead of letting it sit alongside your real sessions, because suspicious activity that piles up unnoticed on an account tends to make every future login look riskier, not just the one that was actually a problem. In your fondness, avoid bouncing the same account across a bunch of unrelated networks back to back in a short window if you can help it, since that's exactly the shape of activity the risk model is watching for. If you already know you're about to switch networks, say you're heading to the airport or moving between offices, just expect a possible re-login as a normal cost of that, rather than assuming something on the app itself has gone wrong. If you're hosting a bot or a user bot for anything serious, keep it on infrastructure with a clean, stable IP rather than cheap shared hosting that's already changed hands across a pile of unrelated traffic before you ever touched it. A dedicated IP that's only ever carried your own account's traffic builds up a trust history that's entirely yours, and that history is worth more than the money you'd save going with whatever hosting was cheapest that month. None of this makes the occasional login prompt disappear for good, and it shouldn't, because it's a normal part of how Telegram protects sessions rather than some flaw the developers forgot to fix. Treating it as a security feature instead of a glitch will save you a fair bit of frustration the next time it happens on a plane, on a new office Wi-Fi, or right after you've switched to a proxy you haven't used before. If you're running Telegram on infrastructure that keeps tripping these checks instead of staying quiet in the background, that's the exact problem we solve. Manage Telegram hosting and proxy infrastructure on dedicated SG hardware. And you can read more about how we set it up over at telegramvault.org. If you found this useful, subscribe for more breakdowns like